Good morning to everyone. Myself Saraswati, Assistant Professor from Department of Civil Engineering. Today we have see a topic of dimensional analysis. The contents of dimensional analysis or introduction of dimensional analysis, units and dimensions, Rayleigh's method, Buckingham's pi theorem, hydraulic similitude, model studies. Dimensional analysis is a mathematical method which is of considerable value in problems which occur in engineering. Dimensional analysis is essentially a means of utilizing partial knowledge of a problem when the details are too obscure to permit an exact analysis. Dimensional analysis is also known as partial analysis. Problem is partially solved and still require experimentation to obtain a functional relationship. Then units and dimensions. The variables used in engineering are usually expressed in terms of limited number of basic dimensions, namely mass capital M, length capital L, time capital T, and sometimes temperature Q. Then velocity, example, velocity V is length by time. The dimensional variables L, M, L, T, they have to substitute length is capital L and time is T. Then length by time is LT minus 1. Then force capital F, mass into acceleration, ml t power minus 2. Then viscosity, Newton second per meter square, ml minus 1 t minus 1. Then flow rate Q is meter cube per second, L cube t power minus 1. Hence most physical quantities we deal with have only three basic dimensions, M, L and T. Then method of dimensional analysis. There are many methods of dimensional analysis. The techniques have been progressively refined over the years. Then oldest method is Rayleigh's method and most famous method is Buckingham pi theorem. All methods are absolutely depend on the correct identification of all the factors which govern the physical events being analyzed. Then Rayleigh's method. Consider a problem involving a scale model test of a hydraulic machine. The thrust force capital F, velocity V, viscosity and density R of the fluid is given including a typical size of system, capital L is also given. The questions must be posed, namely how to analyze a plot the data in the most informative, how to relate the performance of the model to that of the working prototype. This is a few example. In capital F is small f of R, V, M and L. The form of function is completely unknown, but it has been proposed earlier. The function must be in the form of a power product. There must be a dimensional balance between both sides of the equation. From equation 1 may be rewritten as capital F equal to K into R power A, V power B, M power C, L power D. For dimensional homogeneity, the dimensions on left hand side must be equal to right hand side. For expressing the quantity in equation 2 in terms of its dimensions, F is denoted as ml t power minus 2 in equal to K, R is ml minus 3 power A, then V is LT minus 1 power B and small m is ml minus 1 t power minus 1 power C, then capital L is L power D. For equating the indices for M, L and T, M we have to calculate M 1 equal to A plus C. Next we have to substitute L 1 equal to minus 3A plus B minus C plus D and T is minus 2 equal to minus B minus C. Then we have three equations but four unknowns. The complete solution is not attainable. Then A is 1 minus C, B is 2 minus C, D is 2 minus C. Then substituting for A, B and D in equation 2, we have to get f of K into R power 1 minus C, V power 2 minus C, M power C, L power 2 minus C. Then next we move on to Buckingham pi theorem. This is perhaps the mother of all dimensional analysis methods. The Buckingham proposed that if a physical phenomenon was a function of m quantities and n fundamental dimensions, the dimensional analysis would produce m minus n pi groups. Each pi should be function of n governing variable plus one more quantity. The governing quantities must include all fundamental dimensions. The governing quantities must not combine among themselves to form a dimensionless groups. Each pi is dimensionless. The final function must be dimensionless and therefore dimensionally f of pi 1, pi 2, etc. pi of m minus n equal to m0, l0 and t0. The next we see model studies. Model study is its scaled down representation constructed in a laboratory for testing and observation. The primary purpose of this model study is to predict the prototype's behavior under various real-world conditions, offering a manageable and cost-effective alternative to full-scale experimentation. Then model studies practical use of dimension analysis in engineering. First example is wind tunnel test. This is a crucial for designing aircraft and vehicles, predicting performance by scaling aerodynamic forces from models. Then second one is dam spillway model, used to optimize hydraulic structures, ensuring safe and efficient water flow during floods. Then real world impact from aerospace to civil engineering. Aerospace design. The Buckingham Pi theorem is a fundamental in guiding the design of aircraft, rockets and spacecraft by simplifying complex fluid and aerodynamic interactions. Then civil and hydraulic engineering. It's indispensable for designing efficient pipelines, dams and bridges, ensuring proper scaling and performance in fluid dynamics. Then hydraulic similitude and model studies. In hydraulic engineering, prototype refers to the actual full scale being designed or analyzed, such as dams, spillway or river sections. A model is a scaled down representation constructed in a laboratory for testing and observation. The primary purpose of this model study is to predict the prototype's behavior under various real-world conditions, offering a manageable and cost-effective alternative to full-scale experimentations. The scaling law and their application in hydraulic model. The application of scaling law paramount in hydraulic model for free surface flow such as those found in spillway, open channel or riverine systems. Fluid number similarity is a typical governing criterion. However, for flow where viscous effects and turbulence are significant, Reynolds number consideration become critical, governing the ratio of inertial to viscous force. The challenge often arises because it is usually impossible to simultaneously match all dimensionless number. Example, both fluid and Reynolds number in a single model, especially when dealing with different fluids or scales. Then practical example of hydraulic model studies. Model studies are routinely conducted for dams, spillway, canal and reservoir to optimize stability, manage energy dissipation and ensure efficient flow conditions. The studies help predict potential scour, erosion and cavitations. Thank you.